Every year, the United States Mint produces billions of coins. Pennies, nickels, dimes, quarters. Each begins as a plain metal disc before being transformed into the currency millions of Americans touch every day. Today, we're going straight onto the production floor to see exactly how coins are made from raw metal to finished currency. No introductions, no fluff, just the complete process, start to finish. The creation of a coin starts with its metal. Large furnaces melt precise combinations of copper, nickel, and zinc. Pennies use a zinc core coated in copper. Nickels use a copper-nickel alloy. Dimes and quarters use a layered structure, a pure copper core sandwiched between copper-nickel sheets. Inside induction furnaces reaching over 1200 degrees Celsius, these metals liquefy into bright orange molten alloy. The furnace tilts and pours the metal into long molds, forming heavy ingots that will eventually become thousands of coins. Each ingot is checked for purity with advanced spectrometers, ensuring the alloy matches exact U.S. Mint specifications. Once cooled, the thick ingots are cleaned and fed into massive rolling mills. With each pass through the rollers, the metal becomes thinner, longer, and more uniform. The goal: achieve the exact thickness required for each denomination. Sensors constantly measure thickness to a tolerance of 1/100 of a millimeter. A strip too thick will jam the presses, too thin, and the design won't fully strike. After dozens of passes, the strip reaches its final form. Hundreds of feet long, smooth, shining, and ready to become coins. The long metal strip now enters high-speed punching presses. These machines stamp out thousands of round discs per minute, creating what the Mint calls blanks. These blanks are the undeveloped form of a coin. No heads, no tails, no detail. The leftover skeleton of the strip is immediately shredded and recycled back into the melting process. Each blank rolls onto a conveyor belt, where cameras scan them for cracks, discoloration, and imperfections. Only perfect blanks move forward. At this stage, the blanks are too hard for precise striking. They must be softened. Blanks travel through long annealing furnaces, heated to around 700 degrees Celsius. This heat relaxes the internal structure of the metal, making it easier to mold during striking. After annealing, the blanks pass into tumbling drums filled with cleaning solution and ceramic beads. This removes oxide layers and polishes the surface. When complete, each blank has a smooth, satin-like finish suitable for striking. The next machine squeezes each blank between rotating dies, raising the edges to form a protective rim. This is called upsetting. It serves a critical purpose. The raised rim prevents the design from wearing down during circulation. Every denomination has a precise rim height, measured by laser heads as the blanks pass through the line. Different coins require different edge styles. Dimes and quarters use reeded edges, those tiny vertical grooves that prevent clipping and counterfeiting. Nickels and pennies have smooth edges. Specialized machines apply these features at high speed while monitoring alignment, depth, and consistency. If an edge is even slightly misaligned, the blank is immediately removed from the line. While blanks are prepared, the dies that will strike each coin undergo their own process. A die is a steel tool engraved with the coin's design, the portrait, the inscriptions, the mint mark, and the year. These dies are created using ultra-precise laser engraving systems. After engraving, dies are hardened through heat treatment so they can withstand millions of strikes. Each die is inspected under magnification to ensure every element is sharp. A single flaw will be reproduced on thousands of coins, so precision here is critical.
Zoom in on the milling error highlighted in red.
Confirmed. The strike appears slightly off-center as well.
This is the heart of the mint, the place where a blank becomes a coin. High-speed coin presses feed blanks between two dies, the obverse and the reverse. With a force between 100 and 1,000 tons, depending on the coin, the press strikes both sides simultaneously, imprinting the raised artwork into the softened metal. The process takes milliseconds. The portrait of Washington, the words, "In God We Trust," the year of minting, all appear instantly. A single press can strike more than 700 quarters per minute. Advanced optical systems immediately inspect each coin for weak strikes, double strikes, misalignments, or die breaks. Coins with defects are rejected on the spot. For collectors and special editions, the Mint produces proof coins. These are struck multiple times at slower speeds to achieve razor-sharp details and mirror-like surfaces. The blanks used for proof coins are individually polished. The dies are treated to produce a deep, reflective finish. Each strike adds more depth and clarity to the design. Every proof coin is handled by gloved technicians to avoid even microscopic scratches. After striking, circulation coins move into large rotating barrels filled with stainless steel media and cleaning agents. This process, called burnishing, removes grease, debris, and sharp burrs. It gives coins a clean, professional finish. Once polished, the coins are rinsed and dried using warm air blowers. Some commemorative coins receive an additional protective layer, an invisible polymer film that prevents tarnishing. The coating is applied using precision sprayers or vacuum deposition systems. Quality sensors measure coating thickness to ensure uniform protection. The U.S. Mint uses one of the most advanced inspection systems in circulation manufacturing. Each coin passes under high-resolution cameras capable of detecting flaws smaller than a grain of sand. Algorithms analyze over 100 attributes: strike clarity, lettering edges, rim height, reflectivity, and surface defects. Coins that fail inspection are blasted off the conveyor with precisely timed air jets. No human hands are needed. The line never stops. Perfect coins reach the counting machines. These machines sort and count thousands of coins per minute with pinpoint accuracy. Once counted, coins drop into heavy-duty bags. Each bag typically weighs 50 pounds and contains a precise number of coins depending on denomination. RFID tags and barcodes are attached to track each batch throughout the distribution chain. The sealed bags are stacked onto pallets, wrapped, and moved into secure storage vaults. From here, armored trucks transport the coins to Federal Reserve banks across the nation. From the reserve, they will make their way to commercial banks, businesses, vending machines, laundromats, and pockets all across the country. What began as raw metal just hours ago is now official U.S. currency, ready to enter the heartbeat of the American economy. Billions of coins, countless strikes, precision, engineering, and security at every step. This is the complete process inside the largest U.S. minting factory, where America's coins are born.